Hey there fans, welcome back to the Quill workshop. Today we're going to build a 12 volt DC power distribution box for a custom lighting project. This project is perfect for anyone looking to add some unique lighting to any of their projects. First thing is our materials. Here's all the materials we're going to need for this project. I have an enclosure that I printed out of PETG on my bamboo carbon. It has this cool sliding dovetail, breaks it out in two pieces. And I'll have to glue back in place before it's complete, but I will probably end up reprinting this anyway. So I have a 50 watt 12 volt power supply here. I purchased that from Amazon. 6 illuminated rocker switches. Fuse holder. And I did a little bit of testing on this circuit before I started, but let's finish this thing off and put it together. I've grabbed a couple hand tools here. We have crimpers, some strippers, a few other hand tools, drill, some 16 gauge wire, and a multimeter to make sure we get everything wired up right. Alright, well, let me get on this, guys, and we'll see how it goes. First we'll add these terminal strips to the enclosure, to this piece of plywood I have. I'm just using this for a mock-up. It should fit inside through the container here when we're done. So we're going to have a separate ground and hot terminal strip for this project. So, and we'll probably end up gluing this into that enclosure before we're all said and done. This little mat from Temu has been a real solid add to the shop, man. It's been nice. Keeps everything from sliding around. Keeps me from losing everything. I do like it. Using my little Bosch drill. I do like this thing. I've had this for years. It's been a solid addition to the shop. You can definitely tell it's done some work. Alright, so now we have everything mocked up. Basically we've got all the ground legs tied into the ground rail, jumpered on this, and some hot that are going to fuses. I'll move the camera and get it closer to this, and we'll start wiring the circuit. We'll connect the power source to the fuse block, add the switches, connect to the terminal block. We'll use the 16 gauge red for the positive side and black wire for the ground. I'll use crimps for all the installation, all the connections, so I'll be crimping everything with crimps. Somebody's going to get the camera set up a little bit tighter for you guys to see what's going on. Alright, this should be nice and tight on this. Now I've got some 16 gauge terminals for this wiring. Now I've only got to do that 3 more times. You always want to test your connections after you crimp them to make sure they're not going to pull off too easy. It's another tip. Then I tend to always strip off a little bit more than I need. I don't know, I've been doing this stuff for literally decades and I still make the same, I don't know if mistakes or whatever you want to call it, inconsistencies. Nice. Alright guys, we've got each of these 6 terminal strips, or toggle switches, tied to the fuse block. The power supply is sending plus 12 volt DC to this power block and distribute these fuses. Well, there's a little safety cap on here. We'll probably have to remove that later on, but don't want to use it, so I'll lose it, so we'll keep it right there. Now I need to run additional wiring to the hot rail, and I need to run a ground wire. So I'll start working on that next. But I'll use the black wire for this part. Alright, so this ground wire, right in black, will go from this terminal block here. And it's got little bridges on it, so it'll bridge this connection to all the other ones. So we'll have a whole ground rail here that will that we want. And I've been debating how I want to do this. I'm just going to leave this like so and tie it into here. So if everything went right, we should have one nice ground rail. And before anybody gets concerned that I'm working on this thing hot, it is only 12 volts, but it is also not plugged in. We are being safe. I'm going to go ahead and do a quick little test on this to see how she's going. Hopefully there's no arcing or sparking before we get too far along. So at this point we don't have our hots from our switches going anywhere, but you can see, I hope this shows up on camera, these LEDs. Got a blue circuit, so that is lighting up. It's passing current, or could, to the side of the terminal. There we go, we've got our ground done, and we've got our switches all wired. Now we have to wire our switches to the terminal strip. Make sure we unplug it. We'll get back into the red wire again. Well, guys, we've got 3 of the conductors, 3 of the switch hots landing to the terminal strips. We'll have 3 different circuits. We got 3 more to go. Slowly but surely, we're working through it. A lot of this stuff's just repetition. It's just same process, procedure, repetition, and you get a good result. So let's finish this thing up, and I'll talk to you guys in a little bit. Well, this is the last connection. I hope you got a good look of it at the camera. I'm new to this whole YouTube thing, and where to put things and line things up so you guys can see it is going to be a learning process for both of us. So we'll look at this in post. But anyway, we've got everything electrically where it needs to be. There's a ton of more work to be done with this as far as cleanup, wire routing, things of that nature. But let's go ahead and test the box, guys. Let's see how she does. So I'm going to go ahead and, so if you guys can see it there, it's all hot, so I hope that doesn't cause any problems. Hope you guys can see that. But I will move the camera again to give a wider shot to see me actually doing the electrical testing and testing each of these circuits. Alright guys, hopefully you can see this. We're going to grab the old multimeter here. Very cheap Amazon, I'm sure. Who knows where I got it from. But I will set it to DC volts, 20 volt scale. I think should work for our needs. We'll go ahead and we've powered it on already. So look, we should have the LED comes on, so only circuit 1 should be hot right now. So we're going to take the meter to the ground leg. Anywhere in the ground leg should work. And we should have, it shows 12 volts on this rail. So this has voltage. The rest of these should not. We're going to go ahead and check to make sure we don't have any shorts or misconnections or anything like that when we do that. So only 1 is hot. I'll go ahead and turn 1 off. Turn on 2. 2's hot. Not too worried about having shorts because I've tested that one, but we're going to go ahead and test number 3. 3 looks good. 4. Yep, she's good. And 5. Yep, we got voltage on 5. And 6 is hot and nothing else is. I'll try to do some balancing act of holding this here. So I'm just holding on the ground terminal and the number 6 terminal. So we have 12 volts, 12.3 volts, which is what we want. So it looks really good for what we have our needs. So we'll get this enclosure snapped back together. Again, this is made out of PETG on my X1 Carbon, my bamboo printer. I love that thing. So what we found with testing is that each switch independently powered a terminal on the block. And this will fit inside there. There's still some more work to do. We have to do something for these switches. We have to get a pass through here. And I'll probably redo the entire enclosure. But our 12 volt distribution box is complete for this video anyway. Great way to add custom lighting to any project. Always be careful working with electricity. Thanks for watching, and we'll see you in the next one. See you guys.
Dwarven smiths in rock and flame unite. Through marble veins, veins of stone, their crafts ascend, legends we've known. Axes sharp and shields divine, grit and sweat mixed with ale so fine. Heavy hammers strike with thunder's call. In